Okay. Okay, we've got this quiz. We want to understand what's going on here. Now, there's a simple rule. We're doing a square root. I can group x to the 7th into 3 groups of x squared. Okay. I can group y to the 12th into 6 groups of y squared. And 8 is, well, you can do a group of, 8 is 2 times 2 times 2. So you can have group a couple of 2's and then 1 left over. Okay. And of course, when you group the x squared, you get 6, or the x to the 7th, you get x squared 3 times, but you get an x left over. Well, let's write that out. It gets a little bit long. I would do y to the 12th. I'm going to change this. I just want to write out all those y's. And we'll go y to the 6th. Okay. Now I can write this out reasonably easily. It'll be a little long, but first of all, we do prime factorization with this number. Okay. Means we just divide it by 2 until we can't divide it anymore. And then we divide it by 3 if that works until we can't divide it anymore, until we end up with all prime numbers. And people are doing that. So x to the 7th is, I'll just write it, x times x times x times x times x times x times x. And then we got y to the 6th, and that's y times y times y times y times y times y. I got them all in there. That last one was a little bit funny. Okay. Now I can group a couple of these 2's, and I can group the x's in pairs. There's 1 left over, just like there's a 2 left over here. And I can group all the y's. Okay. So I can write this as, okay, I'm going to do all of these first, then I'll have these 2 left over. Okay. I'm going to write this then as the square root of two squared times x squared times x squared times x squared times y squared times y squared times y squared times 2 times x. The ones that aren't paired up, I'm going to just slap on the end. Okay. And of course, that's the square root of 2 squared times the square root of x squared times the square root of x squared times the square root of x squared times the square root of y squared times the square root of y squared times the square root of y squared times the square root of 2x. Now, why did I do that? It's because the square root of 2 squared is 2. Why is that? Well, let's just consider, what's the square root of 36? Well, everybody's going to be able to tell me that that's 6, right? Why is that 6? Because 36 is 6 squared. Okay. And the square root of 6 squared is 6. So square root of any number squared is just that number, unless the number is negative. And we'll deal with that idea a little bit later. Okay, so this is then square root of 2 squared is 2, square root of x squared is x. Well, we got 3 of those. And square root of y squared is y, and we got 3 of those. And then we still have a square root of 2x left over. Well, then that's just 2x cubed y cubed times the square root of 2x. Make sense? Okay, well, we'll kind of wall these off. We'll deal with these in a minute. Well, that always works. When you're doing square roots, that's what you do. If you're doing a cube root, you got to group these into 3's. If you're doing a 5th root, you group them into 5's. Okay? And we'll do that. But right now, and once you understand the principle here, it isn't hard to see what you do here. Okay? So how can we do that a little shorter? consider square root of x to the 7th, right? How would that be grouped? You'd have 3 groups of x squared and you'd have an x left over. So you don't really have to write all this out to see what's going to go on. Okay, so the square root of, and I'll write 8 as 2 cubed. Okay. I'm going to go ahead and do it like this. Okay, I can write the even numbered powers. Now, why do I write the even numbered powers? Because I know those can be grouped in pairs. And I can write them the square root of 2x here, so that this times this, and the 2x times the 2 squared and the x squared and x to the 6 and y to the 6 give me what I started with. Okay. Now, the square root of 2 squared times x to the 6 times y to the 6th. I know that I can group 2 squared. Well, the square root of 2 squared is 2. Well, I know that the square root of x to the 6th then has to be x squared, x cubed, because I have 3x squareds in here, right? Now I'm going to write it out in a little more detail. I'm going to say this is the square root then of 2 squared times x squared cubed times y squared cubed. Does that make sense? Because x squared cubed means x squared times x squared times x squared. That's x to the 6th. Y squared cubed is y squared times y squared times y squared. Can't be y times y, y times y, y times y. That'd be y to the 6th. And I don't want to square root that. I should have written this last because that's what I did earlier. It's where it is. I'm going to write it out. Okay. Well, what's the square root of 2 squared? It's 2. What's the square root of x squared cubed? Well, it's just going to be x cubed, right? Yeah. The square root of x squared is x. Okay, so we could do it like this. We end up with the same result. Okay, well, let's take this as an example and see what we do with this one, okay? We have the cube root of 16 a to the 10th b to the 12th. Now, first of all, we write this as 16 is 2 to the 4th power. Okay, divide 16 by 2, you get 8. Divide 8 by 2, you get 4. You divide 4 by 2, you get 2, and you have 2 left over. That gives you 4 2s. That's 2 to the 4th power. Now we group things in 3s. Okay. How many groups of 3 would you get from A to the 10th? You got 10 A's written out there. You got 3 groups of 3. So let me just write out, okay, square root of A to the 10th. Is the square root of A cubed times A cubed times A cubed, right? Times A. Because A cubed times A cubed times A cubed is 3 A's written 3 times with an A left over. And it's a cube root. Okay. That's the cube root of A cubed times the cube root of A cubed times the cube root of A cubed times the cube root of A. Which is then A times A times A times the cube root of A. So when we look at A to the 10th, we can imagine writing this out. We don't have to write it all out. We know that this is going to represent 10 A's all written together. We can group them into 3 groups of 3, which means that we're going to have 3 A's when we come out of it. So let me write this now as the cube root of 2 cubed times the cube root of 2 times the cube root of A to the 9th times the cube root of A times the cube root of B to the 12th. Makes sense? I can do that? Is that clear just based on what all these things mean? Okay. So what's the cube root of 2 cubed? 2. 2, because what do you cube to get 2? Okay. Should have left myself room to write this out. Now, yeah, everybody understands this, I think. Okay, so I'm going to erase it. Just to give myself a little bit of room. It's relatively. Cube root of 2 cubed is 2. And okay, what we're going to do is we're going to do this, we're going to do this, and we're going to do this, and then we'll have these left over. Okay. What's the cube root of A to the 9th? A to the 3rd. It's A to the 3rd because you group 9 A's into groups of 3, you get 3 of them. So this is A to the 3rd, now mark that the cube root of A to the 9th is the cube root of three groups, three A's. That's a cube root of an A cube, cube root of an A cube, cube root of an A cube. Okay. The cube root of b to the 12th is what? For the same reasoning,
B to the 4th.
yeah, it's going to be b to the 4th, okay? Because you can have four groups of three b's. And the same thing, you can write it out, you can visualize it in your head. Okay. That's 2a cubed b to the 4th. And then we have the square root of 2 cube root of 2 cube root of a. We have these two terms. Well, that's then 2a cubed b to the 4th times the cube root of 2a. Now, when you look at it this way, another reason you get a cubed here is because you can divide 9 by 3 and you get 3. Okay, why would you divide 9 by 3? Because you got 9 A's and you're going to group them in threes, right? Okay. And let's make sure we can see all this. The camera zoomed back. Let's zoom it in a little bit so that we lose that part of the board. And we'll come over here. And now the board is blurry there. Okay. That's still in focus. Okay, if we do the cube root of b to the 12th, well, 12 divided by 3 is 4. You take 12 b's and group them into 4 groups of 3. Yeah, let's discuss this a little bit. Okay, since it's come up, I'm going to go ahead and talk about a topic that you're going to need for next time anyway. Okay, I was going to, not going to do it quite this way, but finding that our tutoring center kind of jumped the gun a little bit, no fault of theirs, but they went to fractional exponents, which I've always found easy. So from what we've done here, we can actually kind of adapt and talk about fractional exponents. So a little bit out of the order of what you got in your assignments and your open math. I'm going to talk about it since Mark is talking about it. Okay. Okay, so okay, well, the cube root of any number, let's just say z, can be written as z to the 1/3. Okay. Now, by the rules of exponents, this is because I'm still really on the camera's way over here. Okay, because by the rules of exponents, if you multiply 2 powers of z, you add the powers, right? If you multiply 3 powers, you add those powers. And there's a reason for that that goes back to something very similar to what we're doing here. But there's the rule, okay? So this is z to the 1/3 plus 1/3 plus 1/3, which of course is z to the 1, which is just z. So if you cube z to the 1/3, you get z. So the cube root of z can be written z to the 1/3. Again, cube root of z is whatever you cube to get z. Another reason you could say that, or we can say this. When you take a power of a power, you multiply the powers. If you don't remember that, and if that's not kind of second nature to you, you probably want to review exponents, okay? The rules for exponents. Did some time ago. Because that can get a little fuzzy, but there's a good reason for it. Okay, so all this means that you can write this as z to the 1/3. So I don't know if I've got room to write this, but let's see what I can do. I'm trying to decide how I want to write this. Yeah, I'm going to need, I'm just trying to see how to get it on one board. I can't see how to do it. So I'll pull up another board. Okay, we got this, okay. So the cube root of first thing I'm going to do, I'm going to write this. I didn't do 2 to the 4th, I'm sorry. Let's do it in 2 steps. 2 to the 4th, a to the 10th, b to the 12th. I'll write it like this. Now I've written all these where the powers and multiples of 3, right? Okay. Well, I can then say, okay, this is 2 cubed times a to the 9th times b to the 12th times 2 times a, all raised to the 1/3 power. Which is 2 cubed 1/3 times a to the 9th to the 1/3 times b to the 12th to the 1/3 times 2a to the 1/3. Now 2 cubed to the 1/3 is 2 raised to the 3 times 1/3. And then a raised to the 9 times 1/3. B to the 12 times 1/3, and that should be 1/3 of 1/2. Apparently when I wrote a 2 here, my brain failed to adapt quickly. Right. So we get this. Now, this really is the same thing we did there, because essentially when we write this as 2 cubed times a, and then a to the 9th times a, and then a b to the 12th, we pull out the powers that are multiples of 3. The same thing we do if we were writing it out this way, just another way to understand it in a way that can be a little bit slicker. So if you understand this, good. If this helps you understand that, good. If it doesn't, we'll go over it again a little bit later. But again, since our tutoring center is talking about it, we want to try to understand it. Okay. Well, let's look at the last one and see what we're going to do. Let's take whatever ideal works best for you. And the 5th root of 128, a to the 11th, q to the 15th. Think first, you don't have to write it out, but think how you would write this out if you had 11 p's in a row, 15 q's in a row. And of course, 128, I'll just tell you, is 2 to the 7th power. Okay. So I'll give you a start on this. And you would have gotten that, but I didn't want you to have to do all that division, even though it's easy. So whatever idea makes the most sense to you, go ahead and do it. Okay, just sticking with square roots for a little while. What do you think 2 times the square root of 47 plus 5 times the square root of 47 would be? Okay, there's a pretty obvious answer, but let's just see how that answer is justified in terms of the rules.
10 times the square root of 47. Yeah, 10 times the square root of 47.
Okay, you can factor out a 47 there, right? So it's 2 plus 5 times the square root of 47, which is 7 times the square root of 47. So it's safe to say that if you got 2 of these and you got 5 of these, you got 7 of them, because they're the same thing. Okay. Now let's try one that's a little more complicated. Let's say you got 2 times the square root of 5. 25. Yeah. Plus 5 times the square root of 50. Our question is, of course, we know the square root of 25 is 5, right? How would we write the square root of 50? How do we simplify the square root of 50? Okay, it's 5 times square root of 2 times 25, right? Which gives us 10 plus 5 times the square root of 2 times the square root of 25. Well, square root of 25 is 5. Now we can multiply these 5s and we get 10 plus 25 times the square root of 2. Now, I'm going to give you another one, see if you can work it. Okay. Square root of 16 is 4, right? So I'm going to write this down below because that's where most of you did it. So that's 4 times 4. That's easy. Okay. And then what do? We simplify the square root of 32. Now, there are 2 ways to do that. You can see maybe the 32 is 16 times 2. Okay. So let's write that over to the side here a little bit. A couple of ways to do this. Square root of 32 square root of 16 times 2. 16 is the biggest square that'll go into 32. So that's the square root of 16 times the square root of 2, which is 4 times the square root of 2. So 32 is 4 times the square root of 2. Now, if a lot of times you have to go to a prime factorization, and if you've got to do that, which you probably don't on 32, but it'll work if you have to. Square root of 32 is the square root of 2 to the 5th, which is the square root of 2 to the 4th times 2. Okay, which is the square root of 2 to the 4th times the square root of 2. Then you know what to do with 2 to the 4th. You just group that into two squares, right? And that gives you 4 square root of 7, because I wrote my 2 like 7. 4 times the square root of 2. So one way or another, square root of 32 is 4 times the square root of 2. End up with 16 times 12 square root of 2. Okay. Okay, one more example. A little more complicated, but this is much simpler than ones you did earlier. So you want to simplify the square root of 18x. You want to simplify the square root of 27x squared. Okay, can't take too much time on this. I'm going to give you a little bit of a hint. Square root of 18x
Yeah.
18 is 3 times 3 times 2. Okay. You divide 18 by 2, you get 9. Of course, 9 is 3 squared. So you could see this as a square root of 9 times 2 times x, knowing the square root of 9 is 3. But if you don't know that, you can write it out more completely. Now, we're going to do that 27. Okay. Now, 27 is 3 times 3 times 3, right? Okay, so what do we have here? Well, 3 times 3 is a perfect square, so we can write this as a square root of 3 times 3 times the square root of 2x. Now, square root of 2, square root of x doesn't give us anything we can really deal with, okay? At least not without a calculator. Okay, so here we have then 2. Well, what squares do we have in here?
3x.
We have the square root of 3 times 3. We have the square root of x squared, and we have the square root of 3, right? And the square root of 3 times 3, that's of course the square root of 3 squared, that's 3. times the square root of 2x. And then this is going to be 2. Square root of 3 times 3 is 3. Square root of x squared is x. And we have a square root of 3 here. Okay. So. Okay, we need to. Talk quickly about how you multiply. Expressions like this. So let's say we got 2 plus 3 times the square root of 5. We want to multiply that by 3 minus 4 times the square root of 7. How do we multiply this? Well, I don't have time to have you work it out, but you know that this is just a couple of binomials. You're going to use the distributive law. So that's real straightforward. 2 times this plus 3 square root of 5 times this. Okay. Then we multiply the terms. We get 6 minus 8 square root of 7. And then we get 3 square root of 5 times 3. Well, that's going to be, I'll write it up, 3 square root of 5 times 3 minus 3 square root of 5 times the square root of 7. So we're just doing the distributive law and writing it out carefully. So we get 6 minus 8 square root of 7 plus 9 times the square root of 5 minus 3 times the square root of 5 times 7, because the square root of 5 times the square root of 7 is the square root of 5 times the square root of quantity 5 times 7. So gives us this. Well, there's a little more we can do with it, but that's basically it. We just use the distributive law. Everything works out. Okay. Well, there's a trick. What if I wanted to do 2 plus 3 square root of 5 divided by 3 minus 4 square root of 7? Well, we do this thing called rationalizing the denominator. Okay? We multiply this by 3 plus 4 square root of 7 over 3 plus 4 square root of 7. Whichever term has the square root on it, we change its sign. Well, if we do this, it's going to work out. We're going to get 6 plus 8 square root of 7 plus 9 square root of 5 plus 12 square root of 35. And you know what? When I did this, I left something off, didn't I? I had a 4 here, and I don't have the 4 here. So I'm going to put the 4 out here on the end. Now it's right, I think. Check my arithmetic and watch me. Okay, so anyhow, this is our numerator. That's what happens when I multiply this by this. Now, you can do that. You just use the distributive law and there it is, okay? The denominator is going to give me 3 times 3. Three times 4 squared root of 7 is 12 squared root of 7 minus 4 squared root of 7 times 3. So that's 12 square root of 7 minus 16 square root of 7 times the square root of 7. You don't necessarily have to follow every step, but if you write out the distributive law in detail, I put 3 dots here to indicate that you want to write out more detail than I did. But it's detail that you know how to do. We've emphasized the distributive law, you know how to use it, okay? Now, what happens here, and this is what's kind of neat, the numerator pretty much stays the same. In the denominator, we got a 12 square root of 7 and a minus 12 square root of 7, which goes together and gives just plain old 0. In the denominator, we're going to have 9 minus, well, 16 times the square root of 7 times the square root of 7. What's the square root of 7 times the square root of 7? It's 7. Do the arithmetic. 16 times 7 is 102. 9 minus 102, I believe, is negative 93. Or put the 93 there, we'll just put the negative outside in front. And now our denominator is just a plain old integer. So we've taken this thing and we've written it so that the denominator is going to be an integer. And there are advantages to that. There used to be even more advantages to that when we had to do calculations like this using tables. We didn't have calculators, okay? And we didn't have anything that would do square roots, at least nothing that anybody could afford, okay?